Now that we've learned the core technologies of 5G, let's see the three major 5G scenarios and their applications. First up is eMBB. eMBB can bring ultra-high transmission rates to users. Some typical eMBB applications are VR, AR, and MR, with VR offering a particularly immersive experience. A downside of VR is that it requires extra equipment, such as a headset. In VR, you know that everything you experience is fake. Likewise, AR requires glasses to be worn in order to interact with virtual objects present in the real world. MR is similar to the technology used in the Iron Man movie, whereby the workbench projects interactive images. Many VR and AR devices available on the market are expensive and fail to live up to their expectations. A cloud-based 5G network with ultra-high rates will help us experience Ultra HD and immersive VR without the need for purchasing high-specification computers. MMTC is an IoT application that brings massive connections. A key goal of 5G is to connect 1 million devices per square kilometers, which has seen NB-IoT be officially included in 5G standards. Prior to this, 5G can only deliver high-speed and low-latency services, limiting its impact on the development of massive connections. However, NB-IoT makes massive connections possible. Next up is URLLC. As mentioned earlier, URLLC applies to self-driving and remote surgery. Why is low latency important for these services? It's because machines are extremely sensitive to latency than humans are. So if the latency for self-driving vehicles is high, even by only dozens of milliseconds, the system will respond too slow and endanger people's lives. Here, we'd like to present some data about latency evolution. In 3G era, the network latency was about 100 milliseconds. So if we drive at 80 km per hour in a self-driving vehicle, the braking distance is about 3.33 meters. In 4G, the braking distance is cut to 1.67 meters with a latency of 15 milliseconds. And in 5G, the braking distance is slashed to 3.33 centimeters thanks to its latency of only 1 millisecond. Therefore, low latency is critical for applications that have high security requirements. And this even extends to remote surgery. Latency during remote surgery could potentially be fatal for the patient. After understanding the three application scenarios of 5G, let's have a look at the 5G solutions. We provide operators with business solutions in three domains, with them being 2C, 2B, and 2H. Now I will briefly explain these three different solutions. After researching the 2C industry, we have found that to achieve success in the 2C field, operators need to provide consumers with good networks that deliver diverse content and flexible multi-dimension tariffs. Looking back at history, it took 9 and 6 years, respectively, for 3G and 4G networks to serve 500 million users. We predict that it will take only 3 years for the 5G network to acquire 500 million users. In the 2C field, there will be a large number of potential 5G users, meaning a strong network is paramount. We talked earlier about two available networking modes, NSA and SA. SA networking mode can provide users with a superior 5G experience. Diverse content is another key factor. 5G can bring us many new services, such as new radio, new live broadcast, and games. Bring an area of entertainment to consumers and helping operators win the market. The last factor is flexible multi-dimensional tariffs. After a large number of new services emerge, consumers are most concerned about charging standards and tariffs. If operators can provide flexible charging standards for consumers, for example, different packages for users using different service types, such as charging users who often use live broadcasts based on high uplink bandwidth, or gaming users being charged based on the low latency and high downlink bandwidth. They will be more satisfied with the service. Those are the three key factors for operators to achieve success in the 2C field. Now, let's have a look at the solutions that Huawei provides in this field. Huawei can provide users with VR or AR services. VR glasses are used to connect to the 5G network that is connected to the VR cloud platform to provide high rates for VR devices. On the cloud platform, we can manage different VR services in a unified manner. On top of this, various VR services are available, such as VR music, VR gaming, and VR live broadcasting. This solution ultimately aims to help operators develop fully convergent video services in the video era and become competitive. As for the solutions in the 2B field, our industry insights shows that there are many opportunities for 5G in the business or enterprise domain. But the more opportunities, the harder it is to make a choice. So we say connectivity opens up the blue ocean market. It is better to start from the connection. The 5G 2B market has great potential, but is hindered by a mature business model. The B2B market needs to develop step by step, starting from connections with mature business models, and then expand to cloud and industry applications. Therefore, we will first focus on typical scenarios such as private LAN, private network, and campus, and these models can be replicated quickly. Following that, we will enter the network plus vertical industry scenario. Then we can have a look at the solutions in the 2B industry. Here, we will divide the solutions into two aspects. First are fixed private lines. AR routers can be used for enterprise private networks to meet enterprise VPN and security requirements, and achieve low cost and fast deployment. In terms of video surveillance, cameras with built-in 5G modules are used for easy installation and provide HD video surveillance services. Second are wireless private lines. We release the industrial-grade CPE in the remote control field to provide more stable connections in complex environments. In addition, the CPE can be used for the remote control of some high-precision instruments, made possible by low 5G latency in live broadcasts. We have launched the video codec with built-in 5G modules. The 5G backpack that comes with this is lighter and provides longer battery power supply, helping journalists shoot HD videos outdoors. As we near the end of the course, let's see how operators can achieve success in the 2Edge field. Huawei provides the FWA solution for homes, which is short for Fixed Wireless Access. Nowadays, the FTTH used is still wired, meaning the optical fiber is used and led from a base station to each residential area, then to a router in each household to provide wireless services for users. With 5G networks, we can replace optical fibers with wireless networks and directly connect base stations to home routers to provide wireless services for users. FWA applies to 3 scenarios. These are connect unconnected household, replace copper lines, and replace optical fibers at homes. In FWA, 5G CPEs are used. CPEs come in a variety of types for different scenarios. For example, in densely populated urban areas, we provide millimeter wave CPEs, whereas in common urban areas, common CPEs are used. During this course, we have introduced the hottest wireless communications technology around 5G. We have covered its evolution, industry development process, and key technologies, as well as 3 major 5G application scenarios, including MMTC, URLLC, and eMBB. We also covered the solutions of 5G. If you want to learn more about 5G technology, please attend other 5G courses. And that's all for today's course. In the next course, I will be introducing you to the widely used industrial IoT gateways in wired communications. Factories are one of the most important IoT scenarios. But what makes them so different to other scenarios? You can find out in the next episode. Thanks for your watching and see you next time.